In the dim silence beneath the Franco-Swiss border, the air was thick with anticipation. Miles below the surface, buried in a labyrinth of tunnels and magnetic coils, the 3I/Atlas chamber waited, a structure built not only of steel and circuitry, but of human ambition itself. For years, scientists had whispered of this moment, a controlled release of pure photonic energy so intense that it could briefly bend the fabric of space itself. They called it the beam. On that night, 3I/Atlas was ready. 3I, short for integrated ionized illumination, was not an ordinary experiment. It was the culmination of decades of research into high-energy photon convergence, a study of what happens when light is forced to behave like matter. At its core, Atlas wasn't built to destroy or weaponize. It was built to speak, to communicate with the universe in its own native tongue, energy. The objective was deceptively simple on paper. Using superconducting field stabilizers and quantum-calibrated mirrors, the 3I/Atlas team would channel light through a fusion-assisted plasma conduit, compressing photons to a density never before achieved by humanity. What they wanted to observe wasn't destruction, but creation. For decades, theoretical physics had suggested that under certain conditions, light could generate mass, that when photons reached a critical intensity, their collective energy might warp the vacuum around them. This phenomenon, known as vacuum polarization, was considered almost mythical, a prediction that hovered between quantum theory and cosmology. But if 3I/Atlas succeeded, that myth would become measurable. The countdown. As the final systems aligned, the facility entered a reverent hush. Every scientist in the control room knew what was at stake. On the giant display board, numbers descended in rhythmic sequence, T-60 seconds. Within the main chamber, magnetic rings began to hum. Plasma stabilizers flickered to life, their halos of blue light spinning faster and faster as containment fields reached critical synchronization. At T-10, a final confirmation came from Dr. Arya Novak, the lead physicist on the project. Photon density aligned. Field stabilizers at full integrity. Initiate sequence. Her voice was calm, but her hands trembled slightly as she keyed in the final command. Then, silence. A low vibration rolled through the earth. And for the briefest fraction of a second, the darkness beneath Europe turned into something else entirely. A beam of pure light, focused, perfect, and impossibly bright, erupted through the chamber and fired upward through a vertical plasma column, piercing the upper layers of the atmosphere. Observers on the surface reported a flash that lasted less than a millisecond, yet illuminated the night sky across 5 countries. It wasn't an explosion. It wasn't a flare. It was something the world had never seen before, light behaving as if it carried mass. The energy pulse propagated outward, brushing against the thin boundary between the ionosphere and the vacuum of space. But then, something unexpected occurred. Instead of dispersing as light normally would, part of the beam bounced back. A faint return signal was detected on Atlas receivers, a modulated pattern encoded within the beam's residual photons. It wasn't random noise. It carried structure, rhythm, and amplitude variation. For several hours, researchers struggled to interpret the data. Initial theories suggested quantum interference from Earth's magnetic field, but as the signal repeated at precise intervals, another possibility emerged, that the beam had interacted with the very fabric of spacetime, echoing through the quantum vacuum and returning distorted, yet deliberate. In that moment, 3I/Atlas had effectively conducted the first conversation between humanity and the universe itself. When the playback began, every person in the control center stopped moving. Across the screen appeared a dense series of waveforms, energy fluctuations too precise to be natural background noise. When converted into visual frequency, the patterns formed a coherent symmetry, a mirrored lattice of photonic intensity. Mathematically, it looked like an answer. Some described it as a standing resonance, a reply formed by the universe's own laws reacting to our interference. Others saw it as an emergent property of quantum spacetime, something self-aware in the physics of existence itself. Regardless of interpretation, one truth became undeniable: 3I/Atlas had reached a threshold never crossed before, the point where human creation touched cosmic structure. In the days that followed, data flooded in. Instruments recorded anomalies in local gravitational gradients. Nearby satellites detected microlensing effects as though a faint gravitational field had been briefly created by the beam. Light had, for a fraction of time, warped spacetime. It confirmed a long-theorized but never proven prediction of Einstein's equations, that under sufficient energy density, photons could generate curvature in the vacuum itself. To the outside world, the event made headlines as a breakthrough in high-energy optics. But within the scientific community, whispers began to circulate: had humanity just created an artificial gravitational signature using light alone? If so, the implications were staggering. It would mean that light, the purest, most ancient form of energy, could be manipulated to produce effects once reserved for the realm of black holes and stars. For the first time, humans had bent the rules of creation not by mass, but by information encoded in light. Within days, 3I/Atlas became the focus of every major scientific institution on Earth. Quantum physicists, cosmologists, and engineers dissected every byte of data. Some claimed this could lead to breakthroughs in controlled quantum gravity, propulsion physics, and even interstellar communication. Others urged caution. Dr. Tobias Venkman of the Max Planck Institute issued a warning in his report. "We have touched something that exists beneath reality's surface. We must not assume it is ours to command." But for most, the emotion was not fear, it was awe. Media outlets dubbed it the light that spoke back. Philosophers compared it to Prometheus bringing fire from the gods. In classrooms around the world, children watched recordings of that blinding pulse and wondered, had we just glimpsed the mechanism of creation itself? Weeks later, when analysis of the reflected signal resumed, researchers found an even stranger anomaly. Embedded within the photon pattern was a microfrequency shift, not random, but ordered, as if encoded. The structure resembled modulation used in early communication signals, repetitive, layered, and self-reinforcing. It didn't spell words or images, but it demonstrated intent, a system trying to organize chaos into coherence. Dr. Novak, reviewing the data, summarized it best. "It's as if the vacuum tried to answer in the only way it could, through the rearrangement of energy itself." Her statement sent ripples through both the scientific and philosophical communities. Was the universe, in some abstract way, aware? Could creation, at its deepest level, recognize when it was being observed, and respond? For days after the beam event, sensitive instruments around the world continued to record faint distortions in the atmosphere above the facility. The ionosphere shimmered with subtle electromagnetic waves, forming ripples visible in satellite imagery. Astronomers noticed slight lensing effects, a curvature too small for the naked eye but detectable in starlight measurements. It was as though a tiny window into the early universe had briefly opened, and then sealed itself. Even more curiously, several deep space observatories detected coincidental bursts of radio static at the same spectral band used in the 3I transmission. No one could confirm a connection, but the coincidence added fuel to the growing mystery. Months later, when the dust of scientific debate began to settle, the meaning of the event grew larger than the data itself. Across universities, temples, and online communities, people debated what it meant for humanity to have, in effect, sent light into the void and received an echo. Was it a glimpse into the hidden architecture of spacetime? A byproduct of quantum resonance? Or had we, for the briefest instant, awakened a form of cosmic self-recognition? Whatever the explanation, one truth resonated with everyone involved: 3I/Atlas was not merely an experiment in physics, it was a mirror held up to existence. By creating light of such magnitude, humanity had forced reality to answer back. And in that answer, even if only through waves and numbers, many heard something almost spiritual, a reminder that science and wonder are not opposites, but reflections of the same yearning to understand. 6 months after the transmission, a joint CERN-MIT paper revealed the final analysis. Buried within the modulation of the returning light was a pattern consistent with nonlinear temporal feedback, a self-referencing loop that implied the signal was altered by its own past emission. In simpler terms, the beam appeared to have interacted with its own future reflection. This phenomenon, dubbed quantum retrointerference, had been theorized but never observed. It suggested that, at extremely high energy densities, light could entangle with itself across time, creating a feedback echo that bridges past and future states. It was not communication in words, but a dialogue in physics, a whisper across time. The scientific community reacted with cautious disbelief. If confirmed, it would mean that the 3I/Atlas experiment had briefly created a situation where cause and effect became intertwined, where information moved both forward and backward in time. One physicist summed it up simply. We didn't just send a signal into space. We may have sent it into time itself. Today, the 3I/Atlas event remains one of the most debated and inspiring moments in modern science. Some believe it marks the dawn of a new era, the first experiment to reveal that light, the fundamental building block of the cosmos, can act as both message and messenger. Others caution that we have only begun to understand the depths of what we touched that night beneath the Earth. Still, even the most skeptical researchers agree on one thing: for that brief instant, the human species became an active participant in the universe's grand dialogue, not merely observers, but contributors. We had reached beyond the known, and the unknown had whispered back. As the archived footage of the beam continues to circulate across digital space, its brilliance still defies description. It was not merely an act of science, nor a feat of engineering. It was something deeper, a convergence of curiosity, courage, and cosmic poetry. In a way, the 3I/Atlas transmission stands as a symbol of humanity itself, fragile yet daring, grounded in knowledge yet drawn to the stars. We sent light, our oldest companion, into the vast darkness, asking a silent question. And somewhere, in the endless geometry of creation, the universe answered. Perhaps not in language we can yet translate, perhaps not in words at all. But in the flicker of energy that returned to us, one message seemed clear. You are part of the light.